You're watching the 3.10 lesson video on graphing linear inequalities, Day 2 notes. We're going to dive right in. This is a continuation from the 3.9 video, so if you haven't watched 3.9, make sure that you do that first. Okay, so what we want to do in example number 1, it says determine if each of the following points are solutions. So what we're going to do is we are going to take a look at each one of these points, and we want to find out if it is indeed a solution to this inequality. All right, without further ado, -3, -7. Is that a solution? It sure is. It's in the shaded area. All right, how about the point 7, 5? Nope, not in the shaded area. How about the point 6, 0? Not 0, 6, 6, 0. 6 to the right, 0 up and down. Yeah, that's a solution. It's in the shaded area. How about the point 2, 5? Nope, not in the shaded area. All right, and last but not least, -3, +7. Ooh, this one's a tricky one because it's on a dashed line. But remember, dashed lines are not really solutions. So if it's on a dashed line, it is not a solution. Had that been a solid line, we would have said that -3,7 was a solution. Okay, number 2 says, what is the inequality above written algebraically? Ooh, this is fun. Okay, so the first thing that we should probably do is get our equation, this is an inequality, but let's write it in slope-intercept form. So y something mx plus b. I think that you guys could easily find the slope and the y-intercept, so let's go and do that first. My y-intercept is 5, so it's going to be +5. And y is something compared to my slope, so let's find the slope. There's a nice point. There's a nice point. So we're going down 2 to the right, 1, 2, 3. So my slope is 3/2 x. Okay, now normally we would throw an equal sign right there and call it a day, but we're dealing with an inequality. So we need to figure out, is this a greater than symbol or a less than symbol based on the shading? Looks like we're shading below, so if you are thinking less than, you are correcto. And we also want to know, are we going to underline it like less than or equal to, or just leave it plain old less than? It's a dashed line. Less than. But you know me, I love to check my work. So let's go to our calculator and we're going to graph it, okay? Can't graph it in function mode, so delete and move it to relation. Y is less than, so control equals. We can get our less than symbol. 3/2 x plus 5. And oh my goodness, something is wrong. Did you see what just happened here? Well, clearly the calculator's wrong, right? Because I'm perfect and I never make mistakes. So let's look and see. 3/2 x, that's it. All right, so what is weird about our graph? Our graph is pointing up and this one is pointing down. Oh my goodness. Look what happened. Do you see what happened? Some of you probably saw me make that mistake before and you were yelling at the screen. You're right. There's an issue there. This should be a -3/2 x. So we don't have to graph it all over again. I want to show you something cool. We're going to hit tab and then the up arrow and magic. And then we can use our arrow to put the negative sign where it needs to be, and let's push enter. And it's hard for me to tell what points are where, so I'm going to go into the menu change my trace step to 1, menu, trace the whole inequality, 0, 5, 2, 2, 4, -1, and something still is happening. What is going on? Oh my goodness. Is there another mistake? And yes, there is. So as you can see, we wrote our slope incorrectly. Our slope should be rise over run. So our slope should be change in y over change in x. Okay, so let's fix our slope accordingly to be -2/3. And again, let's practice again on our calculator, hitting tab, up arrow, and let's change this to our -2/3 and push enter. Okay, still looks good, but again, we just learned that it's very important to go into the menu and actually trace it. We've already changed our trace step, so now we can see our y-intercept is 0, 5. Our next point is 3, 3. So much better. 6, 1. Oh my gosh, I'm loving it. 9, -1. And now we can see that we graphed our inequality correctly. Okay, so lesson learned. Whenever you're trying to write inequalities, there's a lot of room for error. So make sure that you're using your calculator as a checking device. If you didn't have your calculator and you didn't do that with me, pause the video now, rewind it, go grab your calculator, and do this problem with me. Okay, now, question number 3. We'll go through this one a little bit quicker now that we just had a lot of calculator practice and practice with being careful with our work. Let's graph this inequality and check using technology. All right, so we got to get y alone, right? Y is not alone. We need to have this in slope-intercept form. So the first thing that we're going to do is we're going to add 4x to both sides so we can get y alone, or just move it over and make it positive. And then got to get y alone. So if you want to divide everything by 3, you are correct. You're a rock star. Y is greater than or equal to 4/3 x minus 7. All right. So 0, -7 is my y-intercept. Should write that out over here. My slope is 4/3, which means up 4 to the right 3. 4 to the right 3, up 4 to the right 3. We're going to seal this, so up 4 to the right 3. Okay, so now that I have this, I got to figure out, is my line solid, dash, shade above or below? Because I have a greater than or equal to sign, that means I am going to be able to use a straight edge to connect all of my points. Straight, extend, arrows, label. So let's label it with the original. 3y minus 4x is greater than or equal to -21. Okay. And then it's a greater than symbol, so we need to shade above. Okay. Let's hope we didn't make mistakes this time. Control Doc, add a graph. I am going to have relation mode. So 3y minus 4x is control equals greater than or equal to -21. Hit enter, and it's looking pretty good. Solid line, shaded above. You know the drill. Menu, trace step change to 1. It's becoming really repetitive. Good. Menu, trace, graph trace. 0, -7, 3, -3, 6, 1. Looks to me that number 3 we did a nice job with.